Hi, I'm Jonathan Harrison, and today I will be presenting Jono Tetris, my Comp 3016 Coursework 2 project. Okay, so this is my game. It's similar to Tetris, but unique in many ways. In this game, you can see the next tetromino block in the top right, and then you have to also clear the lines, just like in Tetris. You can sort Tetrises, which are up to 4 line clears in one go, and the unique points of this game can be shown through here. Okay, so the next Tetris piece will be a purple piece, which means that it's a chaos piece. Now these chaos pieces use post-processing effects to um, invert the screen and also move it around a bit to make the player confused pretty much. Just like this. So what happens there is if you don't clear a line, then the post-processing's effect will be applied to the render buffer and then rendered to the screen. I've also added bombs, which use particle effects and this texture of the sprite renderer to render to the screen the bomb, which will then explode a 3x3 radius on the board. The audio for this game uses the Erklang library to play 2D sounds by using their sound engine. For this I had to import WAV files and also MP3 files to the game and then just play them with the sound engine. In a bit we'll see a Tetris, hopefully, and this uses another post-processing effect where the screen will shake when a Tetris is scored, like that. This just adds to the juiciness and entertainment of the game and will hopefully make it a better playing experience and a bit different to the classic. The score is based on how many lines you get. So for one line clear, you get around 40 points multiplied by the difficulty which you're at. And then if you get 2 to 3 line clears, it's like 60 points. And for a full Tetris, you get 100 multiplied by the difficulty. So you can see that as the game gets increasingly hard, you will get more points. The difficulty actually works by just increasing the rate that the pieces fall down after a certain amount of ticks. So in this I have it set to the piece should automatically fall down by one place in the grid every 20 ticks, but as the difficulty increases this then also goes up at the same time, and therefore at the end, which is difficulty 20, you'll only have 2 ticks until the piece is forced down, which makes the game quite hard. The collision detection for this game works by checking the 4x4 array of the Tetris piece compared to the real locations of all the pieces in the board. So to do this, I had to check the offset of the Tetris piece and its current position on the board, and then check if any of the pieces of this 4x4 array were then in contact with either the sides of the walls or the pieces on the board. Once you reach the top, the game is then over and your score is displayed. You can either press enter to restart or escape to quit the game. The main chunk of this game is held in the game class. This holds the state data and also most of the logic for the game. In this class, you can see that it holds the board, which is a 1D array. This has the borders as well, and it's used by creating or defining the board height and the width, and then timesing these together to get a 1D array of the board. The score and difficulty are also held here alongside the user's key presses and also the next Tetris piece and the Tetris piece coming up. Initially, I had planned on making the board and Tetris pieces out of 2D arrays where I would store them similar to this, and each value would have an X and Y value. However, I thought that would be overcomplicated for this solution, and I decided to use a 1D array instead, where I just index the values like so, and I can obtain the value at any point using this maths where I get the y value times by the width of the board or the Tetris piece, and then the x value, and then this gets every single indexable point. The Tetris pieces are also stored like this, and then indexed in the Tetris class or the Tetromino class of my game. And they're all stored in 4x4 arrays. However, this caused some problems later on when I came to rotate each of these pieces. Using this rotation method, I found that these two rotated pieces worked fine in the 4x4 grid. However, the other ones would need a 3x3 grid instead, as when you would rotate them, the intended rotation would look like this, which would occur in the 3x3 grid. However, if you did it in the 4x4 grid that it was currently stored in, it would rotate and move not from the center point, but from this 4x4 grid, and it would move all over the place, and for the user this would look quite strange. As most of the pieces required the 3x3 rotation, I made another class for this where it has its original 4x4 grid, and it has this top row and column removed, meaning that only this part of it remains. And once this is done, I then do the rotation in this 3x3 grid, and then it will come out to the desired product, and then I insert this back into a 4x4, and once that's done, I put it back into the current object Tetris piece and use that as the final rotation for the piece. Each Tetris piece in the game is held in the Tetromino class. This contains a vector for the game object, which is each of the blocks involved in the Tetris piece, which will always be 4, because every Tetris piece has 4 blocks. It will also contain the Tetromino index, which will decide from which of the 7 Tetris pieces it will be, as well as the rotation index and the offset of the x and y value to show where it is in the current board. It also has this, which is the 1D array for the Tetris piece, and it will be containing zeros and ones for where the pieces are. The index is taken from this Tetrominos class, where each piece is stored like this in the 1D array, and then stored into the Tetros vector, which stores all these arrays, and then is called upon whenever it needs. Each piece from the board and the Tetris pieces are stored as a vector of game objects. So each little block from a Tetris piece or a piece on the board will be stored as a game object, which will have a position compared to the actual orthographic view of the view space, as well as the size and the color in GLM Vec3s and Vec2s. The rotation is also stored, as well as the texture used for that individual object. This is then drawn to the screen using the draw class or the draw function, which can be seen here. The draw function simply just gets all of the values of the actual object and takes it to the renderer, where it is then drawn as a sprite. The renderer of this game works by first creating a VAO and VBO for the whole screen. This is then applied to the quad VAO, where buffers are generated and each object is used with the shader to first get the correct transformations and the scale of the texture, and then applying this to the VAO, where it is drawn using GL triangles and then bound to the actual VAO and rendered to the screen. Creating a game using OpenGL has taught me a lot about graphics and shaders, as well as post-processing effects and just game development in general. For this course, I hadn't coded any games or anything this in-depth before, but I think at the end of it I've come out with a nice, robust game that plays quite well and is actually quite fun. I'm quite proud of the project, honestly, and I think if I were to do it again, I'd definitely have learned a lot of nice tricks and tips for next time, and I'll definitely be able to relate this to my final year project, which I'll be doing as well. So, all in all, I think this has been a very good project, and my knowledge of creating games and creating graphics as well has increased dramatically. And yeah,